So here's another example of integration by parts. We have the integral of t squared times the sine of t dt. T squared is a polynomial expression, while sine of t dt is a trigonometric function. So if we're using the Lipit, I'll let u equal t squared because p comes before t. So u is equal to t squared, and dv is equal to the sine of t dt. du is equal to 2t dt, and v equals negative cosine of t. Now we use the formula uv minus the integral of v du, and that's going to give us t squared times negative cosine of t minus negative 2t cosine of t dt. And now we're going to use parts again for this integral right here, because substitution will not work, because it would probably be the easiest in this case. Same thing, we're letting u equal the polynomial expression first, which is just going to be negative 2t. Actually, you know what? Let me change the color of this. Just kind of have a bit of a integrateception or something going on in here. Integrateception. Yeah. Okay. So u equals negative 2t, and dv equals cosine of t dt. Du equals negative 2 dt, and v equals sine of t. So this right here is going to take us to uv minus v du, which is negative 2t times the sine of t minus the integral of the negative 2 times the sine of t dt. And this just becomes, the whole thing is going to be negative 2t sine t minus 2 times the cosine of t, because the derivative of cosine is negative sine. So your final expression, your final answer is just going to be negative t squared cosine of t minus all of this. Don't get that confused, because this minus sign is still right there. And we integrated everything in here. So what we'll have is the integral of t squared sine of t dt equals negative t squared cosine of t plus 2t sine t plus 2 cosine of t plus c. And there's your answer. So here's another example of integration by parts. We have the integral of q to the fifth times the natural log of 5q dq. Q to the fifth is a polynomial expression, and natural log of 5q is a logarithmic expression, so we're going to let u equal the natural log of 5q, and we're going to let dv equal q to the fifth dq. And we're going to differentiate and integrate with u and dv respectively. So starting with finding du. Du is equal to 1 over q dq. And v is equal to q to the sixth over 6. And now we use uv minus the integral of v du, which is going to leave us with the natural log of 5q times q to the sixth over 6 minus the integral of q to the 5th over 6 dq. Because I just divided q to the 6 over 6 by q. And now that's going to equal q to the 6 times the natural log of 5q over 6 minus, we're going to integrate q to the 5th over 6, and that's going to give us 1/6 by pulling out this fraction right there, times q to the 6th over 6, and that's going to equal, as a whole, the whole expression is q to the 6 times the natural log of 5q over 6 minus q to the 6th over 36 plus c, and this is your answer right here. So this example of integration by parts that we have here is the integral of y over the square root of the quantity 5 minus y dy, and let u equal y and dv equal 1 over the square root of 5 minus y dy. So now you can see that our original expression is equal to u times dv, and we're going to integrate and differentiate for dv and u respectively. So equals dy, and because dv is equal to 1 over the square root of 5 minus y, the same thing as saying 5 minus y to the negative 1/2, v is going to be equal to negative 2 times 5 minus y to the 1/2. You can just imagine taking the derivative of v and getting dv. So now we utilize our formula, uv minus the integral of v du. It's going to go from here, negative 2y times 5 minus y to the 1/2. Let's just leave it as a fractional exponent for now. It'll look better. Minus the integral of negative 2 times 5 minus y to the 1/2 dy. I'm just going to section this off here. And we integrate the expression inside this integral here now, which is going to be easy enough. So we wind up with negative 2y times 5 minus y to the 1/2 minus negative 2 times 5 minus y to the 3/2 times 2/3 times negative 1 because of the chain rule. So now we simplify, and that's just going to be negative 2y times 5 minus y to the 1/2 minus, the negatives cancel here, 4/3 times 5 minus y to the 3/2 plus c. And there is your answer.